So let's get started with our next part. तो पिछले वीडियो में हमने देख लिया था एग्जाम्पल वन, जहां पर हमने कैलकुलेट किया था फोर्स, और वो आया था 733 न्यूटन। तो चलिए आगे देखते हैं एग्जाम्पल टू। स्टार्टिंग फ्रॉम द रेस्ट, व्हाट विल बी द महिंद्रा's velocity आफ्टर 1 second if he is falling down ड्यू टू द ग्रेविटेशनल फोर्स ऑफ द अर्थ। तो यहाँ पर पूछा गया है स्टार्टिंग फ्रॉम द रेस्ट। स्टार्टिंग फ्रॉम द रेस्ट यानी इनिशियल वेलोसिटी जो होंगी वो जीरो। What will be the Mahindra's velocity after 1 second? So we are having the time t is equals to 1 second. If he is falling down due to the gravitational force of the earth, मतलब वो फ्री मतलब वो फॉल कर रहा है। जैसा कि हमने ऊपर देखा था कि एक ऑब्जेक्ट यानी एक स्टोन को हम जब ऊपर फेंकते हैं तो हमें वो अर्थ के सेंटर के टुवर्ड्स अट्रैक्ट होता है ड्यू टू द ग्रेविटेशनल फोर्स exerted by the earth on that particular object. So we are going to see that what will be the we have to find that what will be the Mahindra's velocity after the 1 second if he is falling down due to the gravitational force of the earth। यानी कि फोर्स जो एक्ट हो रहा है वो ग्रेविटेशनल फोर्स अर्थ का उस महेंद्र के ऊपर जो एक्ट हो रहा है तो उसकी वजह से। So starting from rest position, what will be its velocity? So we are having initial velocity is equals to zero. We have calculated the force that is 733 Newton. So for this numerical, we also have to calculate the force as using the formula F is equals to gm1m2 upon r square, where g is the universal gravitational constant and having the value as g is equals to 6.67 into 10 raised to minus 11 Newton meter square per kg square, and r is the radius of the earth that is 6.4 into 10 raised to 6 meter, and mass of the earth is 6 into 10 raised to 24 kg. So we are having the initial velocity 0, force is equals to 733 Newton, Mahendra's mass as we are knowing that 75 kg, and time which is 1 second which is given us in this example question. So we have to calculate first the Mahindra's acceleration because we have to find out the final velocity. So recall कीजिए कि हमें फाइनल वेलोसिटी निकालनी है। तो न्यूटन की ऐसी कौन सी इक्वेशन है जिसमें एक्सेलरेशन, टाइम, इनिशियल वेलोसिटी और फाइनल वेलोसिटी सब आते हैं। तो अकॉर्डिंग एक्सेलरेशन फाइंड करने के बाद a is equals to f upon m, that is the according to the Newton's second law of motion, f is equals to ma, a is equals to f upon m, which is equals to force we are having 733 Newton and 75, that is the mass of the Mahindra, which comes to be 733 upon 75 meter per second square. So according to the Newton's first equation of the motion, v is equals to u plus at. तो हम न्यूटन की फर्स्ट इक्वेशन ही क्यों यूज कर रहे हैं? तो हम यहाँ पर देख सकते हैं कि इनिशियल वेलोसिटी हमारे पास है u इज इक्वल्स टू जीरो। वी आर हैविंग द एक्सेलरेशन a इज इक्वल्स टू जो हम अभी हमने कैलकुलेट किया है दैट इज 733 अपॉन 75 एंड टाइम t इज इक्वल्स टू 1 सेकेंड वी आर हैविंग। सो वी हैव टू कैलकुलेट द फाइनल वेलोसिटी व्हाट विल बी आफ्टर द 1 सेकेंड ऑफ महिंद्रा। So initial velocity 0 plus 9.77, so 9.77 जो है तो वो आया है यहाँ पर एक्सेलरेशन दैट इज 733 अपॉन 75 इज इक्वल्स टू 9.77 मल्टीप्लाइड बाय 1। सो द फाइनल वेलोसिटी कम्स आउट v is equals to 9.77 मीटर पर सेकेंड। This is 1.83 into 10 raised to 9 times Mahindra's velocity in example 2 on page 6. That means if we are comparing it with the Mahindra's velocity which is in the example 6, example 2 on the page 6. So here we are having the page 6 example number 2. So here the velocity which is we have calculated as we are assuming here the Mahindra is sitting on the frictionless bench. So here it comes to be 5.34 into 10 raised to minus 9 meter per second. And here it is here it is coming 9.77. So we can say that this is 1.83 into 10 raised to 9 times that of the Mahindra's velocity. So according to the Newton's law of gravitation, every object attracts every other object. So this is clear. तो आगे देखते हैं, thus if the earth attracts an apple towards itself, the apple also attract the earth towards itself with the same force. Why then does the apple fall towards the earth but the earth does not move towards the apple? यहाँ पर एक बढ़िया क्वेश्चन पूछा गया है कि अगर अर्थ एप्पल को उसके सेंटर की ओर अट्रैक्ट करता है तो क्या एप्पल भी अर्थ को अट्रैक्ट करता होगा? अगर मतलब जो फोर्स से अर्थ एप्पल को अपने ऊपर अट्रैक्ट कर रही है अपने सेंटर के टूवर्ड्स, क्या एप्पल आल्सो अट्रैक्टिंग विद द सेम फोर्स ऑफ द अर्थ टूवर्ड्स इटसेल्फ? व्हाई देन डज द एप्पल फॉल टूवर्ड्स द अर्थ? यानी एप्पल ही क्यों अर्थ के ऊपर गिरता है? अर्थ क्यों नहीं चली गई एप्पल के ऊपर? So we are going to see these answers to these questions in the latter part of this chapter. The gravitational force due to the earth also acts on the moon, because of which it revolves around the earth. Similar situation exists for the artificial satellites orbiting the earth. Yani, so the similar force, यानी यहाँ पर कहते हैं the gravitational force due to the earth also acts on the moon, because of which it revolves around the earth. यानी जो ग्रेविटेशनल फोर्स अर्थ का है वो मून के ऊपर भी एक्ट होता है, ड्यू टू विच द मून आल्सो रोटेट्स अराउंड द रिवॉल्व्स अराउंड द अर्थ एंड अर्थ इज आल्सो रिवॉल्विंग अराउंड द सन. सिमिलर सिचुएशन एग्जिस्ट फॉर द आर्टिफिशियल सैटेलाइट्स ऑर्बिटिंग द अर्थ. यानी सेम सिचुएशन एग्जिस्ट करती है जो आर्टिफिशियल सैटेलाइट्स है जो कि हम स्पेस में भेजते हैं, जो कि टेलीकम्युनिकेशन एंड ऑल डेटा मिलने के लिए जो हम इस्तेमाल करते हैं. तो सेम सिचुएशन आर्टिफिशियल सैटेलाइट्स के साथ जो कि मतलब रिवॉल्व कर रहे हैं अर्थ के ऑर्बिट में. सो orbiting the earth, the moon and the artificial satellites orbit the earth. The earth attracts them towards itself, but unlike the falling apple, they do not fall on the earth. Why? यानी जैसे मून अर्थ को रिवॉल्व कर रहा है, तो उसी की तरह ये जो सारे आर्टिफिशियल सैटेलाइट्स है वो भी अर्थ के अराउंड जो रिवॉल्व कर रहे हैं. लेकिन व्हाई द आर्टिफिशियल सैटेलाइट्स डू नॉट गेट फॉल ऑन द surface of the earth? This is the same situation as like of the apple and the earth. This is because of the velocity of the moon and the satellite orbit along their orbit. तो ये सब काम, ये जो नेचुरल सैटेलाइट्स जो आर्टिफिशियल सैटेलाइट्स है वो अर्थ के सरफेस पे क्यों नहीं गिर रहे हैं? तो इसका एक कारण है जो कि है वेलोसिटी ऑफ द मून. इफ दिस वेलोसिटी वाज नॉट देयर, दे वुड हैव फॉलन ऑन द अर्थ. अगर ये वेलोसिटी नहीं होती तो ये सारी चीजें अर्थ के सरफेस के ऊपर अर्थ के टूवर्ड्स अट्रैक्ट हो जाते. तो ये कौन सी वेलोसिटी है वो भी हम आगे देखने वाले हैं. सो नाउ लेट्स सी Earth's gravitational acceleration. The Earth exerts gravitational force on objects near it. According to the Newton's second law of motion, a force acting on a body results in its acceleration. तो न्यूटन्स के सेकंड लॉ का जो मैथमेटिकल प्रूफ है, सो वी हैव कैलकुलेटेड दैट एफ इज इक्वल्स टू एम ए. ये जो हमें इक्वेशन मिली थी, फोर्स इज इक्वल्स टू मास इनटू एक्सेलरेशन. और न्यूटन की सेकंड लॉ की जो स्टेटमेंट है, दैट इज द रेट ऑफ चेंज ऑफ मोमेंटम इज ऑकर्स इन द डायरेक्शन ऑफ द अप्लाइड फोर्स. सो according to the Newton's second law of मोशन, जो इक्वेशन है, अ फोर्स एक्टिंग ऑन अ बॉडी रिजल्ट्स इन इट्स एक्सेलरेशन. यानी एक आधी बॉडी मतलब एक अगर बॉडी है, अगर उसके ऊपर अगर फोर्स एक्ट हो रहा है तो उसके वो बॉडी का मतलब एक्सेलरेशन उसका रिजल्ट आता है. Thus the gravitational force due to the earth on a body results in its acceleration. This is called as the acceleration due to gravity. तो F is equals to ma जो इक्वेशन है हमारे पास, तो यहाँ पर F इज इक्वल्स टू एम जी कैसे है? तो यानी अगर किसी ऑब्जेक्ट के ऊपर अगर फोर्स लग रहा है, उस ऑब्जेक्ट का सपोज समथिंग मास है, तो उसकी वजह से जो फोर्स एक्ट हो रहा है तो उसकी वजह से एक्सेलरेशन प्रोड्यूस होता है. जैसा कि हम जब टू व्हीलर चलाते हैं तो हम जब एक्सेलरेट करते हैं, यानी हम फोर्स लगाते हैं तो फोर्स की वजह से एक्सेलरेट होता है और एक्सेलरेशन की वजह से ऑब्जेक्ट मोशन में आता है. तो सेम कंसेप्ट यहाँ पर भी अप्लाई हो रहा है, लेकिन यहाँ पर जो मतलब एक्सेलरेशन जो प्रोड्यूस हो रहा है फोर्स की वजह से वो है एक्सेलरेशन ड्यू टू ग्रेविटी, which is denoted by the small g. Acceleration is a vector quantity, as I have already told that scalar and the vector difference. Scalar is the quantity which is defined with the help of the magnitude only, and vector quantity are those physical quantities which are described, denoted with the help of the magnitude as well as the direction. So यहाँ पर acceleration है vector quantity. So acceleration vector quantity होने की वजह से इसका दोनों होगा, एक magnitude भी and direction B. So we have to define both the magnitude as well as the direction for declaring of the acceleration. As the gravitational force on any object due to the earth is directed towards the center of the earth, the direction of the acceleration due to gravity is also directed towards the center of the earth, that is vertically downward. सो एज द ग्रेविटेशनल फोर्स, जैसा कि हमने ऊपर देखा कि ग्रेविटेशनल फोर्स किसी भी ऑब्जेक्ट पे जो एक्ट हो रहा है वो टुवर्ड्स द सेंटर ऑफ द अर्थ एक्ट हो रहा है. सो क्या एक्सेलरेशन ड्यू टू ग्रेविटी इज आल्सो एक्टिंग टुवर्ड्स द सेंटर ऑफ द अर्थ, दैट इज द वर्टिकली डाउनवर्ड्स? यस, एब्सोल्युटली यस. सो थिंक अबाउट इट, वी आर हैविंग द टू क्वेश्चंस. तो देखते हैं व्हाट वुड हैपन इफ देयर वेयर नो ग्रेविटी. अगर ग्रेविटी ही नहीं रही तो क्या होगा? What will happen if value of the g was twice as large? अगर वैल्यू ऑफ g, जो कि हमने ऊपर देखी थी, जो कि हेनरी कैवेंडिश, देखते हैं हम ऊपर, जो कि हेनरी कैवेंडिश ने हमें कैलकुलेट की थी 6.673 इंटू 10 to -11 न्यूटन मीटर स्क्वायर पर केजी स्क्वायर. मैं आपको ये वैल्यू इसलिए बार बार दिखा रहा हूँ क्योंकि ये आपको इसी समय याद हो जानी चाहिए, इसलिए बार बार जैसे देखेंगे तो वो वैल्यू याद होती चली जाएगी. सो वी आर हैविंग द, यहाँ पर पूछा गया है व्हाट विल हैपन इफ द वैल्यू ऑफ द जी वाज ट्वाइस एज लार्ज. सो अगर जी की वैल्यू है वो अगर ट्वाइस एज लार्ज हो जाए तो व्हाट विल हैपन. तो चलिए देखते हैं इन सारे सवालों के जवाब आगे के इस ग्रेविटेशन चैप्टर में. सो वैल्यू ऑफ द जी ऑन द सरफेस ऑफ द अर्थ. We can calculate the value of the g by using Newton's universal law of gravitation for an object of mass m situated at a distance r from the center of the earth. So पहले देख लेते हैं न्यूटन्स यूनिवर्सल लॉ ऑफ ग्रेविटेशन, जो कि हमने पढ़ा था. दैट इज द फोर्स acting on an object is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. द लॉ ऑफ ग्रेविटेशन गिव्स. सो उसके जो यूनिवर्सल लॉ ऑफ ग्रेविटेशन से है, तो उससे हम ये फॉर्मूला डिराइव करते हैं. एफ इज इक्वल्स टू जी m1 m2 अपॉन आर स्क्वायर. सो वी आर कंसिडरिंग हियर द कैपिटल एम एज वी आर गोइंग टू कैलकुलेट द small g, and small g is the acceleration due to gravity which is acting due to the gravitational force. So here we are going to consider the mass of the earth. So mass of the earth हमने ऊपर देखा था, mass of the earth is 6 into 10 raised to 24 kg. So we are putting all the values, that is f is equals to g m upon r square, and we are having the, according to the Newton's second law of motion, we are having the equation f is equals to ma, but here a is acceleration due to gravity. So we are taking the g, as we have seen that the acceleration due to gravity is denoted by the small g. So g is equals to, as substituting as g is equals to gm upon r square. That is, from the equation 3 and 4, we can calculate this mg is equals to gmm upon r square. And here we are going to calculate that mm will get cancelled and g is equals to gm upon r square. So if the object is situated on the surface of the earth, r is equals to r radius of the earth. Thus the value of the g on the surface of the earth is g is equals to gm upon r square. SI unit of the g in SI units is meter per second square. That is the acceleration due to gravity. That is the unit of the acceleration only. The mass and the radius of the earth are, this is the mass which we have to put it directly in our mind, that is 6 into 10 raised to 24 kg is the mass of the earth, and 6.4 into 10 raised to 6 meter, this is the radius of the earth respectively. Using this we can calculate that g is equals to 6 point, we are putting all the values as we are knowing the value of the g, m and r square. So g is equals to 6.67 into 10 raised to -11, 6 into 10 raised to 24, that is the mass of the earth, and 6.4 into 10 raised to 6 whole square, that is the radius of the earth whole square. So we are going to calculate the value of the small g, that is the 9.77 meter per second square, which is the value of the acceleration due to gravity. So this acceleration depends only on the mass m and the radius r of the earth, and so the acceleration due to gravity at a given point on the earth is same for all the object. It does not depend on the properties of the object. So as we have calculated here the equation for the g, as that is acceleration due to gravity, और हमने यहाँ पर इस इक्वेशन में देखा कि जो acceleration due to gravity है वो सभी कांस्टेंट से, यानी g जो वैल्यू है वो कांस्टेंट है. Mass of the earth, that is the constant 6 into 10 raised to 24, r, that is the radius of the earth, that is 6.4 into 10 raised to 6, that is also constant. So we are getting the value of the acceleration due to gravity, that is 9.77, which is constant. So, as we can conclude from this that acceleration due to gravity value will be constant at any point for all the objects on the surface of the earth. So, what would be the value of the g on the surface of the earth if its mass is twice as large and radius half of what it is now? So, यहाँ पर हमें वापस एक क्वेश्चन पूछा गया है. So, what will be the value of the g, which we can be calculated as using the equation g is equals to gm upon r square. So, you have to try this. Variation in value of the g. So, now we are going to see what will be the variation in the value of the g. So, first point, that is change along the surface of the earth. So, will the value of the g be the same everywhere on the surface of the earth? The answer is no. So, because the reason is that the shape of the earth is not exactly spherical, and so the distance of the point on the surface of the earth from its center differs somewhat from the place to place. Due to its rotation, the earth bulges at the equator and is flattened at the poles. Its radius is largest at the equator and smallest at the poles. The value of the g is thus highest, that is 9.832 meter per second square at the poles, and decreases slowly with decreasing latitude. It is lowest, that is 9.78 meter per second square at the equator. So these are the 2 points which I am highlighting. These are the two which you have to remember for your, as we are having also question on this, but mostly it gets asked and it is the important one to remember. So the value of the g that is highest at the poles because of the surface of the earth, it is not a perfect spherical shape. It is flattened at the equator, it is bulge at the equator and flattened at the poles, so due to which the acceleration due to gravity value is 9.832 meter per second square at the poles, and it is lowest at the 9.78 that at the equator. We can also check this why these values are differing at the poles and the equator. तो इसका रीजन है कि जैसा कि हमने यहाँ पर देखा कि g is equals to capital G m upon r square. So r is the radius of the earth. So as we are going to calculate that, that means if we are checking the value of the acceleration due to gravity as the radius of the earth, if we are considering it will be the large at the equator and it will be the less as we are considering from the pole. So, due to the as distance will increase, the acceleration due to gravity will decrease. So, as the uh, it decreases the distance, as the radius decreases, so the acceleration due to gravity value increases. And as the distance get large, so the value of the acceleration due to gravity, that is the 9.78 meter per second square at the equator. Now see that what will be happen when we check it with the help of the change with the height, as we are changing the height now. Firstly, we are changing with the along the surface of the earth. Now we are changing along the height. As we go above the earth surface, the value of the r in the equation 5 increases and the value of the g decreases. However, the decrease is rather small for heights which are small in comparison to the earth's radius. For example, remember that the radius of the earth is 6,400 km. If an aeroplane is flying at a height 10 km above the surface of the earth, its distance from the earth's surface changes from 6400 km to 6410 km, and the change in the value of the g due to its is negligible. On the other hand, when we consider an artificial satellite orbiting the earth, we have to take into account the change in the value of the g due to the large change in the distance of the satellite from the center of the earth. Some typical heights and the values of the g at these heights are given in the following table. तो सो हियर वी आर, तो यहाँ पर इतना बड़ा कुछ बताया गया है. एक सिंपल मीनिंग है कि जो अर्थ का रेडियस है दैट इज 6,400 किलोमीटर, बराबर. So here we have given one situation that suppose if one aeroplane is flying at the height of the 10 kilometer above the surface of the earth. So what will be now the height of that aeroplane with respect to the earth center? That will be the 6,410 kilometer. That 10 kilometer will get added in the radius. So Due to this, as this distance is too much small, so the value of the g will not change at it, as it will be the negligible. It will not mostly affect the value of the g. तो ऑन द अदर हैंड अगर हम दूसरे बाजू से अगर सोचेंगे, तो वहां पर एक सिचुएशन है कि जो आर्टिफिशियल सैटेलाइट जो रोटेट कर रहे जो रिवॉल्व कर रहे हैं अर्थ के ऑर्बिट में, सो व्हाट विल बी देयर इफेक्ट ऑन द एक्सेलरेशन ड्यू टू ग्रेविटी। तो ऐसे कुछ केसेस है जो हमें इस टेबल में दिए गए हैं, वो हम देखेंगे। So surface of the earth average height we are considering that is the zero. So acceleration due to gravity 9.8 meter per second square. No change. As surface is at the lowest level, so height will be the 0 kilometer. Mount Everest पे चले गए। Mount Everest की height 8.8 kilometer. Actually that is the 8,848 meter. But we are considering that is the kilometer as the standardized unit. So 8.8 kilometer. So कुछ ज्यादा इफेक्ट नहीं होगा, 9.8 ही होंगी। मैक्सिमम हाइट रीच बाय द मैन मेड बलून, जो गैस बलून्स होते हैं हीलियम गैस वाले, वो अगर हम कंसिडर करेंगे, सो हाइट अप टू विच दैट दे गोज इन द स्काई दैट इज 36.6 किलोमीटर। सो 9.77 as we see that acceleration due to gravity get decreased as the distance increases, height increases. Height of a typical weather satellite की height 400 किलोमीटर। So acceleration due to gravity or decrease हो गई 8.7. Height of the communication satellite that is 35,700 किलोमीटर, acceleration due to gravity 0.225. तो यहाँ पर हम देख सकते हैं कि जैसे कि हाइट बढ़ती जा रही है, acceleration due to gravity is decreasing. This is because of the formula that we have derived here, that g is equals to gm upon r square. As the distance is increasing, acceleration due to gravity is decreasing. So now we are having the third parameter, that is change with the depth. So what will be the happening with the change in the depth? तो हमने सरफेस पे देख लिया, हमने हाइट पे देख लिया, अभी डेप्थ की बारी। द वैल्यू ऑफ द जी ऑल्सो चेंजेस इफ वी गो इनसाइड द अर्थ। द वैल्यू ऑफ आर इन द इक्वेशन 5 decreases, and one would think that the value of the g should increase as per the formula. However, the part of the earth which contributes towards the gravitational force felt by the object also decreases, which means that the value of the m to be used in the equation also decreases. As a combined result of the change in r and m, the value of the r decreases as we go deep inside the earth. सो यहाँ पर एक जो बात बताई गई है कि अगर हम अर्थ के डेप्थ में जाएंगे, अगर डेप्थ में चले जाते हैं, तो जैसे कि हम देख सकते हैं कि डिस्टेंस जो है वो कम हो रहा है। एज पर दिस इक्वेशन g इज इक्वल्स टू gm अपॉन आर स्क्वायर, एज द डिस्टेंस इज रिड्यूसिंग। डिस्टेंस अगर कम होगा तो एक्सेलरेशन ड्यू टू ग्रेविटी बढ़नी चाहिए, जो कि इनवर्सली प्रोपोर्शनल है। बट एज वी आर यहाँ पर तो हमें बताया गया है कि एक्सेलरेशन ड्यू टू ग्रेविटी की वैल्यू जो है वो बढ़ रही है। So what is the other factor that is affecting this? So the other factor is that the mass. So हम अर्थ के सेंटर के यहाँ पर जा रहे हैं, तो मास में तो कुछ चेंज हो रहा है, जो कि मास है, तो उसमें भी कुछ इफेक्ट हो रहा है, ड्यू टू विच दैट एक्सेलरेशन ड्यू टू ग्रेविटी इज गेटिंग इंक्रीज। सो जो डीप माइंस में जो काम करते हैं लोग, तो उनको जो है अर्थ के अंदर, मतलब जो खुदाई की जाती है तो वो अर्थ के अंदर होती है, यानी कि अर्थ से जो सरफेस से है, वो डिस्टेंस इंक्रीज होते जाता है, ड्यू टू विच द एक्सेलरेशन ड्यू टू ग्रेविटी इज ऑल्सो इंक्रीजिंग। सो यहाँ पर एक क्वेश्चन है जो बहुत बार पूछा जाता है। सपोज वी आर हैविंग द वी आर हैविंग अर्थ सरफेस, so we are digging from the one end of the earth and towards its center. So what will happen to the and suppose हमने एक होल डिग किया। सो डिग करने के बाद जैसे कि हम सेंटर की ओर बढ़ते चले जा रहे हैं, तो एक्सेलरेशन ड्यू टू ग्रेविटी विल आल्सो इंक्रीजेस इन दैट केस। So the answer for that question will be that the value of the acceleration due to gravity will get increasing. So now let's see what we have asked in the think about it. Will the direction of the gravitational force change as we go inside the earth? What will be the value of the g at the center of the earth? So every planet and satellite has different mass and radius. Hence, according to the equation 6, the values of the g on their surface are different. on the moon, it is about one sixth of the value. So keep it in mind this thing. ये ध्यान में रखो कि on the moon it is one sixth of the value on the earth. So what will be the value on the Earth's surface? That will so as we can compare it also with the weight. As suppose one person is having the weight of 60 kg on the surface of the Earth. What will be the weight of that person on the moon surface? So it will be the one sixth of the 1/6 of the weight on the surface of the Earth. That is, it will be the six divide into 60 divided by 6, that is the 10 kg on the moon surface. As a result, using the same amount of the force, we can jump 6 times higher on the moon as compared to that on the earth. तो ये जो बात है, ये ध्यान में रखने जैसी है. And mostly the questions will also be asked on the basis of this. So it is important to remember this, that the value of the uh, uh, value of the weight will be on the one sixth of the surface of the moon. तो चलिए आगे बढ़ते हैं. दो टॉपिक्स जो कि बहुत कंफ्यूजिंग लगते हैं, मास एंड द वेट, उसके बारे में हम देखने वाले हैं यहाँ पर. सो वन थिंग आई वांट टू टेल दैट अगर मतलब जो भी यहाँ पर क्वेश्चन पूछे गए, ट्राई टू फाइंड आउट द आंसर टू दिस क्वेश्चंस आल्सो. एज हमें ऐसा नहीं कि सिर्फ हमें एक्सरसाइज और एक्सरसाइज के क्वेश्चंस जो है वो सॉल्व करके मतलब उससे तो मार्क्स तो आ जाएंगे, लेकिन जो कंसेप्ट है वो हमें क्लियर करनी चाहिए. तो टू मेक द कंसेप्ट एज द स्ट्रॉन्ग, सो बिकॉज कंसेप्ट इज द पावर, दैट इज द मेन मोटो. सो कंसेप्ट हमें क्लियर करते चले जाना है. हमें हर एक जो कंसेप्ट, एक एक जो पॉइंट है, उसका मीनिंग समझ लेना है, और उससे हमें आगे बढ़ते चले जाना है. ऐसा नहीं कि सिर्फ हमने यहाँ पर देख लिया, समझ लिया, हो गया. वी हैव टू थिंक. तो ये थिंक अबाउट द अबाउट इट का सेक्शन हमें इसलिए दिया है क्योंकि हम सोचे. वी हैव टू थिंक अबाउट दैट, व्हाट विल बी द हैपन इफ दिस विल हैपन. एंड वी हैव टू आल्सो थिंक अकॉर्डिंग टू अवर. हम अलग भी इसके बारे में सोच सकते हैं कि ऐसा नहीं हुआ तो कैसा हो सकता है. दैट आर ऑल द अदर सिचुएशंस व्हिच वी कैन मेक ऑन अवर ओन एंड वी कैन थिंक अबाउट इट. सो वी शुड हैव टू थिंक. So we are going to see about the next, that is the mass and the weight. So what is the mass? Mass is the amount of the matter which is present in the object, and the SI unit of the mass is the kg. Mass is a scalar quantity. वापस आ गया. स्केलर क्वांटिटी क्या है? स्केलर क्वांटिटी मैग्नीट्यूड. इसमें डायरेक्शन की जरूरत नहीं, इसलिए मास इज द स्केलर क्वांटिटी. And mostly the this asked in the exams also, it is too important according to it also, distinguish between the mass and the weight also. So it is necessary to learn about this difference between the mass and the weight. So mass is the amount of the matter which is present in the object. The SI unit of the mass is kg. Mass is a scalar quantity. Its value is same everywhere. Its value does not change even we go to the another planet. यानी मास एक ऐसी क्वांटिटी है, एक ऐसी स्केलर क्वांटिटी है जिसकी वैल्यू हम दुनिया के किसी भी कोने में चले जाए, उसकी वैल्यू कभी चेंज नहीं होगी. वो है मास. अकॉर्डिंग टू द न्यूटन्स फर्स्ट लॉ, इट इज द मेजर ऑफ द इनर्शिया ऑफ एन ऑब्जेक्ट. तो इनर्शिया क्या है? इनर्शिया इज द सिंपल टेंडेंसी ऑफ एन ऑब्जेक्ट टू रिमेन इन द स्टेट ऑफ द आइदर रेस्ट और इन द मोशन. तो इनर्शिया हमने हमारे लोअर क्लासेस में हमने इनर्शिया के बारे में देखा है. इनर्शिया ऑफ रेस्ट, इनर्शिया ऑफ मोशन, डायरेक्शनल इनर्शिया. एज इनर्शिया ऑफ रेस्ट इज द inertia that an object to stay in the state of the rest only, and inertia of motion, an object continues to stay in the state of the motion only. And directional inertia is the inertia which is occurred due to the applied force, that is the directional inertia. So we have to think about it also. And according to the Newton's first law, it is the measure of the inertia of an object. Higher the mass, higher is the inertia. So weight. मास के बारे में तो हमने देख लिया. अभी वेट क्या है? वेट ऑफ एन ऑब्जेक्ट इज डिफाइंड एज अ फोर्स विथ विच द अर्थ अट्रैक्ट्स द ऑब्जेक्ट. वेट जो है वो ऑब्जेक्ट का डिफाइन होता है कि उसके ऊपर अर्थ कितना फोर्स एक्ट कर रही है. सो द फोर्स एफ ऑफ एन ऑब्जेक्ट ऑफ मास एम ऑन द surface of the earth can be written using the equation 4. So weight W is equals to F is equals to mg. That is, we according to the Newton's second law, F is equals to mass into acceleration. But here we are going to consider the acceleration is acceleration due to gravity. That means that weight will be mg. G is equals to gm upon r square. So we can write W is equals to gmm upon r square, as we are replacing with the value of the G putting here. Weight being a force, its SI unit is Newton. So SI unit of the weight is Newton, as we can see here. So also the weight being a force, it is a vector quantity. तो मास जो है वो स्केलर क्वांटिटी है, और वेट जो है वो यहाँ पर वेक्टर क्वांटिटी है. यानी वेक्टर क्वांटिटी आ गई, डायरेक्शन भी आ गई, मैग्नीट्यूड भी आ गया. एंड इट्स डायरेक्शन इज टुवर्ड्स द सेंटर ऑफ द अर्थ. डायरेक्शन कहाँ पर है? सेंटर ऑफ द अर्थ के यहाँ. As the value of the g is not same everywhere, weight of the object also changes from the place to place, though its mass is constant everywhere. यानी मास ऑब्जेक्ट का चेंज होगा ही नहीं. मास हम दुनिया के किसी भी पूरे सोलर सिस्टम में कहीं भी चले जाए, mass will remain constant everywhere, but the weight changes as we know that weight is equals to mg, as we have seen earlier that value will change as g value is changing along the surface of the earth, g value is changing along with the height, g value is changing along with the depth. So the value of the weight is also changed according to the surface. So, colloquially, we use weight for both mass and the weight and measure the weight in kilograms, which is the unit of the mass. But in scientific language, when we say that Raju's weight is 75 kg, we are talking about the Raju's mass. जब हम weight की बात करते हैं 75 kg, तो हम actually we are talking about discussing about the mass. What we mean is that Raju's weight is equal to the gravitational force on 75 kg mass. As Raju's mass is 75 kg, his weight on the earth is F is equals to mg, that is 75 into 9.8. That is the acceleration due to gravity on the surface of the earth, which we have seen already. That is surface of the earth, acceleration due to gravity value is 9.8. So here the force or the weight which is acting on the Raju's is 735 Newton. The weight of the 1 kg mass is 1 into 9.8, which is equals to 9.8 Newton. Our weighing machine tell us the mass. एक्चुअली जो वेट वेइंग करने के मशीन होते हैं दैट आर एक्चुअली टेलिंग द मास, एंड मास इज द अमाउंट ऑफ द मैटर विच इज प्रेजेंट इन द ऑब्जेक्ट. But actually, if you want to calculate the weight of an object, so we are going to multiply it with the value of the g, that is the acceleration due to gravity, and the value of the g is 9.8. So actually, if we want to calculate the weight of an object, so we have to multiply it with the acceleration due to gravity, so we will get the weight of an object. And the mass is the actual which is shown by our weighing machines. So two scale balances in the shops compare two weights, that is the two masses. So use your brain power. Will your weight remain constant as you go above the surface of the earth? सोचो इसके बारे में. Suppose you are standing on a tall ladder. If your distance from the center of the earth is 2 r, what will be your weight? So try to think upon it and try to answer these questions in the comment box. Solved examples. So this we will see that if a person weighs 750 Newton on the earth, how much would his weight on the moon, given that the moon's mass is 1.1 upon 81 of that of the earth, and its radius is 1 upon 3.7 of that of the earth. Weight on the earth 750 Newton. Ratio of the mass of the earth to the mass of the moon. That is actually the we are having the moon का जो mass है वो हमें दे दिया है. Actually, we are given the ratio, that is 1 upon 81 of that of the mass of the earth. So if we are taking that mass of the earth upon mass of the moon, which will be 81, ratio of the radius of the earth that to the moon, that will be 3.7, as we have given. Let the mass of the person be mkg, weight on the earth will be mg, which is equals to 750, which is equals to mg me upon re whole square. Actually, this formula has been came from here. G is equals to gm upon r square. Only we are going to substitute as ऐसे में ये न्यूमेरिकल्स बाद में ऑन पेपर सॉल्व करके भी वीडियो लेने वाला हूँ, लेकिन फिलहाल अभी ये चैप्टर के फ्लो में है, सो वी आर गोइंग टू सी हियर ओनली. M is equals to 750 r square upon gm square. Weight on the moon mgmm upon rm square using equation 1. So after doing all these calculations, we are getting that the weight on the moon is 1.126.8 Newton. Weight on the moon is nearly one-sixth of the weight on the Earth. We can write the weight on the moon as mgm. Gm is the acceleration due to gravity on the moon. The gm is the one-sixth of the g on the Earth. So, do you know gravitational waves? Waves are created on the surface of the Earth when we drop a stone into it. Similarly, you must have seen the waves generated on the string when both its ends are held in the hand and is shaken. Light is also type of the wave called as the electromagnetic wave. So electromagnetic wave, this is the light which we will see in the next chapter, that we are having the refraction of the light and reflection of the light and all. So we are going to see what is the electromagnetic wave and all that. I will discuss with in that chapter. Gamma rays, X-rays, ultraviolet rays, infrared rays, microwave, radio waves are all of the different types of the electromagnetic waves. Astronomical objects emit these waves and we receive them using our instruments. All our knowledge about the universe has been obtained through these waves. So gravitational waves are a very different types of the waves. They have been called the waves of the fabric of space-time. Einstein predicted their existence in the 1916. These waves are very weak and it is very difficult to detect them. Scientists have constructed extremely sensitive instruments to detect the gravitational waves emitted by the astronomical sources. Among these, the LIGO, that is Laser Interferometric Gravitational Wave Observatory, is the prominent one, which was used to find out the gravitational waves. Exactly 100 years of their prediction, scientists detected these waves coming from an astronomical source. Indian scientists have contributed significantly in this discovery. This discovery has opened a new path to obtain the information about the universe. So these are all which I think there is then no need to explain about this, as it is a simple one, and it is we should know all this about the gravitational waves, as how they are discovered and how they are found and studied. So next is the major part, that is the free fall, which I'm going to take it in the next video. So now if you are having any doubt, so you can comment in the comment box, as this chapter we will finish mostly in 3 to 4 videos, as because we are taking a lot of the time, so because we are going to see at each and every concept in the detail. ऐसा नहीं कि ऊपर ऊपर से पढ़ लिया. We have to study it in the each and every concept clear. So, and if you like this video, then definitely share, and also suggest, like, share, and the subscribe also. So we will stop here. Thank you.